Hey, hello, welcome to my channel. So today we are going to solve the day 15 challenge, and which is to print all the prime numbers within a given range. Okay, so on previous video we have gone through the this is prime program, which is to find is that a number is prime or not, just by returning not prime or just by returning false or to these things. So now we are going to print all the prime numbers within a given range, right? So for this you need to print the all the prime numbers between the start and end. So from the start to end we have to print that prime numbers. So this is an extension of the previous day's topic, which is to checking if a number is prime or not. So now instead of checking one number, we check all the numbers in the range. Okay, which means we use the same problems from the previous, which is to trying to check which is this number is a prime or not. So same that type of thing we just checks, but we need to print here the number of prime numbers. So let's check what is the hints that ChatGPT was given. Okay, so take two inputs. Okay, just because they will give the start and end, and iterate through all the numbers from the start to end, because start end should be inclusive, because when we using in a range, so that will be use the plus, means it will skips the last one number. So try to include all which is need and which is not need. Okay, because we need from start to end also, means we need from start value and end value, which means if it, for example, start value is a prime number, then we need to print that number also, and same for the end number, which means if it is a prime number we need to print that end number also. So it is including, indicating that it should include, right? So for each number check it is a prime or not. Normally prime numbers is nothing but a number divides the number by 1 and the number itself. For example, 2 will get the two factors of 2 and 1, because it can divide by 2 and 1. It can't divide by, like for example, it can't divide by anyone, right? Yes, they have multiples, but it can't divide by anyone. And same for 3, 3 into 1 3, and 5 into 1 5. Okay, means like you can understand, like 1 and 5 are the two factors. If there are more than two factors, then it is a composite numbers. Okay, that's what the previous video has said. But the negative numbers and the 1 is also not a prime number and a composite number also, so we don't need to include that in the prime numbers, so we need to skip that. Okay, and check the divisibility up to root n, means we have to check the divisibility root n, means it will reduce the time complexity. Time complexity is nothing but to time taken by the program to execute the output. So it will reduces the time by doing the square root. So we need to check this divisibility up to this one. Next, print all numbers that are prime or not. Okay, so that are prime. So let's get into the video so that you can understand easily what we are going to discuss. Okay, in previous video we have seen that is checking is a prime or not by just like limit value, it is nothing but the square root of n. So same logic we will also use in day 15. So okay, I have created a file day 15 which is print all prime in a range. I'm closing the sidebar, and yeah, I'm creating this. So firstly, don't consider this, and I will show you that. Firstly, using it, which is like a simple loop based, right? Step through simple in terms. Yeah, I'm writing the here approach loop based. Let's say, okay. What we need first, we have to go through each and every let us start value and value, so we need to loop that, iterate that, right? So let's say I am creating here a list, okay, which is primes. Okay, because it will stores the prime numbers. Here we need to print the primes range, in this range we need to print the prime numbers, right? So we have, so I'm creating a list to store that primes. Okay, next let's say I am looping, what I am looping from range of values. Like for example, here we have 10 like start value and 20 as an end value. So I am using here a start and end. And I said that range function, see the range function is start, stop and step. Okay, we use only this two, like starts value and stops value. Stops value will really uh, like skips the last one. For example, 0 to 5 numbers we want, then it will takes let's say I want 0 to, or like just like I want 5 numbers in a range. Let's say I'm defining as range of 5. Then it takes as 0 to 4. So we need to print that last 5 number also, because we need to find that last number. If it is a prime, then we need to return, right? So I'm just like plusing that one and checking if number or I is greater than or not. So let's say I'm defining this as a number. Okay, if number is means that start value, let's say it is a start value, let's say 10. If it is greater than 1, why here I am defining this? Because to skip that another values, like negative values, one value, so it will skips that one value also. Okay, or else you want to use like this is equal to 2, whatever we can. Okay, so if number is greater than or equal to 2 or it is greater than 1, so we need to find the logic to print all the numbers, right? So firstly we go through all these numbers. So here checking the divisibility up to root n. Now we need to use the root n concept, square root concept, which is to gives the half of the value. Okay, means for example in the previous we use like this. Limit means it is a square root, just like giving. Int means the math of square root, it is a import function, so it is imported that. So it is like a separate module, so I have imported and use the square root function. In that I have inserted this, so it will also breaks that number into half. You know that, like for example 16 square root is equal to 4, so 25 square root is equal to, like same as like, sorry, 25 square root is equal to 5. Same as like other numbers also we have half the values. For example root of 10 is equal to almost like a 3, so you can also use the calculator for this. For example I am using square root, so almost like a 3. So in that 3.1 I am using that converting to int. Okay, so for that I am used from the 2 to limit plus 1. If this number, for example given number, is divisible by any number in this range, then it is not a prime number, because prime is not doesn't divisible by any numbers, only divisible by the two factors, which is 1 and the number itself. Okay, so same logic here we also use. For which one we use, like for example here check the divisibility of root n, means we take the this value, I think, right? So let's try that. So let's say let name the variable as int of, let's import that math module, import math. So I am using math dot square root, here already giving the suggestions, and so I need to import the include that end value, because we know we need from the last two range of values only. So just by defining the square root we can reduce the number of iterations. Okay, which means like you can understand from the day 14 where we check the last number. By that we we stop the multiples of that end number in this range only. It will indicates that in range. Okay, you can understand slowly so that easily understand. So next we need to print the all numbers. Okay, we need to check that. Okay, so for that checking, so if here I will use the another loop. Okay, let's say it is I from the range of limit. Okay, limit plus 1, let's say, because limit is 3, so that 3 value will be skipped by the range 1. So I am using plus 1, so it will calculate from the 4, so 0 to 3. Are you understand? Let's say it is 3, then limit plus 1 is equal to 4. So range value will skip the last value, so it will ranges from 0 to 3 only. Okay, so from which value I have to check? 2 to, right? So if that number is divisible by any number in this range is equal to 0, then return false. Or else we need to return, what we need to return, like yeah, just like else we can add, we don't need to return, I mean like by returning in this what we can say, or like just like, okay, returning false. Yeah, we have to append this, right? In this primes, I need to append this. What number I need to append? If that number is not, so I'll directly write break. So it directly breaks that loop, and if it is divisible by any number in this range, so it will breaks and automatically returns to the main loop. If it is not divisible by any number, then it will adds in this list. Okay, so for that I need to return that primes. Okay, it will starts from the 2 because the value will start from 2. I mean like prime numbers will start from 2. Let's say I'm running the file. Here we will get the range. For this 10 to 20, this is the range of the prime numbers, and 90 to 26, this is the range of the prime numbers. Okay, so this is the one of the loop. Let's check the ChatGPT was given the same or not. Yeah, it is giving such type of steps here. We use a loop from start to end. Yes, we use the start to end loop. By this, here you can observe that we used almost like two loops. Okay, one loop, and it is another second loop. Okay, it is a first loop. So it is using a loop from starting from end, and for each number. So okay, for each number check if it is a prime. Okay, I am checked that here if it is a prime or not, and reuse the logic from the day 14. Yes, we have checked the same. So here I am using the main point is this, because we are reducing the time complexity, right? So print or store the primes in a list. Yes, I am used this. So let's check what's the ChatGPT was given. Start value given, and end value, it means like taking the direct from the input and directly printing this like this. So just like printing the numbers, so it is not using any list. Okay, so if number is greater than 1, primes are greater than 1, so it should need to aware that use the this condition, which means it is like a edge condition to use this. Okay, because we need only the prime numbers, not need any negative numbers, or not need any 1 2 3, only 1 not 2. Okay, so these are the condition for the prime numbers, right? So we need to check the range, same as like that I have written in the limit. Okay, here directly use the limit plus 1. Okay, so directly checking. If it is not the prime, exit the inner loop. So it is like, so for each number in the range, they check the divisibility rule for the root n. Okay, so if no divisor is found, print as a prime. The else after the inner loop executes only if no break was occurred. Okay, if no break was occurred, then it will appear. Okay, so example, it shows like this. Yeah, I have said right that edge cases to consider when writing any program. So if it is an empty range, like for example 0 and 1, there are no primes because there is no prime from 0 and 1 also, and 0 1 also are also not prime. So 0 and 1 also not prime, we directly return, no primes will return. And negative range, so we need to skip that, negative ranges, and we need to print only the positive integers. Okay, 2 3 6 only, sorry, 2 3 5 only. And start and end values are prime, so then we can directly return the one number. And same start and end not a prime, then we need to not to return anything, because no prime number, so we know output. Okay, reversed range, so we need to handle the separate. Okay, it is an optional check, but it is most not used, but it needs to handle the separate. So if it is large range, then works with a square root optimization. As I said, that it will divide the almost like a half value or like a single value. Such type easily, like we can take that in, not an half value, but mostly decreases the number of approaches for that. Okay, time complexity is like this, and space complexity only variables, so no extra less. This is a best approach, but there is a still have big of n and root n, so we need to decrease. So there are number of approaches for this, so for that I will use the number of approaches. Mainly the last approach will take me to understand that almost like a large time to understand, like so long to understand. You can also try to uh, play with that, so we can go through the each approach so that we will understand what we have to do. Okay, so I have asked number of approaches for this. Okay, it shows that approach one is like simple, trial, division, brute force, like means like we can use the loop and simply searching all this, like simple like a brute force type. Okay, here we didn't used any something like a square root methods. Okay, every number checks divisibility. Here same as like we used in our that primes as a list. Okay, so same as like checking and breaking this. Okay, if divisible not prime, otherwise it is prime. So it's same as like a this, as we discussed about what is same and less than or greater than or equal to and negative numbers. Okay, time complexity is like this, worst case, which means like worstly takes more time, so we need to reduce that. Next approach to optimize, like using square root and using the flag. What is flag? Okay, let's try to understand that what is flag. Okay, so flag is commonly referred to a variable, typically a boolean. Okay, we uses here true or false. Boolean means true or false. Okay, so it is simply like a used to signal a specific condition or state within a program. It acts like a marker that influence the flow of the behavior or the behavior of the application. So you can understand that, for example, I have found even, let's say without founding anything I will make it is false because I didn't found anything even in this array. For example, I am looping that numbers in a array. For example, 1 is taken, n is divisible by 2. No, it is not a even number, so it doesn't will divisible. And 3 will goes, 5 will goes, same, these are like odd numbers. And 2 will goes. Yes, if it is divisible, so then it is executes in this condition and sets the flag when the condition met. So it assigns true, so then it will breaks. And this if found even means if it is true, then prints an even number was found. same as like that, it is a flag. Okay, same as like different approaches they can use. For example, here running true, while running true, user input try to enter the quit. If it is quit means then we return false, else this. Then after again it goes to the while, so checks that while is true or not, but while is false, so it doesn't execute this loop. So then it is like a sets to normal, just like a it is executes, or like enter quit to exit, it like executes. Okay, same as like that, here making a flag for that to tracking or marking that primes range. Okay, so here no need to check the divisors beyond the UN, because if it is, you can understand me slowly. See, for a number in a range, here I am reducing the edge cases, because let's say if given -5 to 5, my range like -5 to 5, then I am checking -5 is greater than or 2 is greater, 2 is greater, so it will check that range to make that only give the positive integer primes. Okay, and end value is normal, like giving that, and same as like giving this, like in the previous we done this, same as like this condition, and this is also same by just like so directly going within this. Okay, so for in this range 2 in the square root, it is also one of the optimization, so checking this, and if it is then append nos, else will return this all these things. Okay, same as like that we done, but here just like tracking, if it is prime then normally it is, we are assuming it is a prime. After it is in the loop, it will gets the false, right? If it is in the loop, for example 2, the for example n is here 10, let's say n is 10, 10 divided by 2, yes it is useful, so it is false, so it will can't append this. If it is false then it can't go in this condition. Same as like all numbers. Okay, no need to, and education is same as like one, but it is faster and larger ones. Okay, next approach is just by using the helper function only. Here see, just here defined a function to find this, is this number is very prime or not, just like giving for this is the list comprehension. In this list comprehension, they uses for number in the range of this, if is prime of this number, then it returns that number. Same as like in this function, just like giving the base conditions and checking with each number. Okay, in the range of this, and same as like the above condition. Next, these are like edge conditions, mostly automatically handled by this conditions, because as I said, like different edge cases may happen, so that will handle this conditions, and above I said like these type of conditions. Okay, I'm scrolling down for the next approach. Okay, third approach was over, and fourth approach, this is the main and useful approach, and it is a very optimized approach. See, here also mentioning that best for the large ranges of values. For example, we given a lakhs of numbers or millions of numbers, then we use this type of approach. It looks like big one, but it will really gives a time complexity is too low. So I have created a word file to explain this. So this is C of Eratosthenes. Okay, Eratosthenes, something that was pronounced. So that here I am removed 0 and 1. What is this? For example, let's go through this. Here I am in the, so I want the prime numbers in the range. Okay, prime numbers in range of C, this method start and end. So in this I created a variable for that this function naming. Okay, so I am returning, and sieve is like given that sieve means it is a prime value. So if it is sieve, okay, are you getting my point? So if sieve of I is true, right, if it is true then return that. Okay, sieve will return true, 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 true or not. Okay, So firstly we will return like this. So first we return, let's say our n is this, means the at our that is our n value is 13. Then let's say we are defining 0 1 2 3 4 5 6 7 till that 13. I am defining here a true type of array. Okay, this is a true type, writing this. So here I am creating index from 0 to this value. Okay, mostly like it will take the range value from 0 to 13, then it will take the 0 1 2 3 4 5 6 7 and still to 12. So I am plussing this, so it almost like we have the 14 numbers from 0 to count. Okay, 0 will count the 14 numbers. So here I am remove 0 1 index because here I am taking based on the index value. To find the prime numbers, I am taking the based on the index value, where prime numbers will start from the 2. So I am going with the 2 3 4 5 6. So we don't need any 0 1 and the negative numbers. So I am removed that. Removed means that is false false. Okay, that will make as, sorry, makes as false. Okay, let's say false, because we start from the, so here I am taking through index as primes and make true or false that prime or not. See, true, if it is 2 is prime, normally we know that true, so 3 is prime, okay, true, and 4 is not prime because I am saying it false after doing the operation. Okay, so normally C of etho something like eratos this will be like this, which is, let's say I am going through each loop like in a range. I am going to true, sorry, 2. Okay, I see a prime number is nothing but it is like a multiples of numbers, like will not be the any prime numbers. Like for example, it should only divide by 1 and the number in itself, right? So for that, I'm decided to like decided to make this 2 multiples or 3 multiples, 4 multiples, 5 multiples, all these index numbers make to false or 0 or anything we can assume. Okay, so I decided to make the except this 2. Okay, except this 3. Okay, why means that except this 2, except this 3, because you can understand. Okay, see, I am going from 2 to 4, so I am going after 2 only. Okay, I am going after 3 only, so I am remove this except 2 because that's why I have written that. Okay, let's say, okay, whatever. So here I have go through the another 2 into 1 is 2. I am not returning that because that is a prime number, 2 and 2 factors, or just like think like that. Or 2 into 2 false, 2 into 3 6 false, 2 into 4, 2 into 4 8 false. Okay, so I am doing all these 2 multiples. Next time take to the 3 multiple, next 3 I am not considering, and 3 ones are 3, 3 twos are 6, 3 multiple or like a like 9 and 12, those are the multiples I have made false. Same for the 4, but 4 here the 2 multiples. See, 2 is a even number, so 2 multiples all are the like even numbers, means 2 will have the multiples like, see, are not not prime numbers, because 4 multiples is also 2 multiples, they already get makes 0. Yes, because see, 4 4 4 ones, 4 twos 8, 4 threes 12 already gets false. So in this then, so no need to check these 2 multiples again, so we don't check the fourth one. And same as like 5, so then I have go through 5, and 5 multiples 10 false, and 5 multiples if it is 15 then it makes it false. Okay, then we goes for the 6. 6 is also multiple of 2 or 3, so no need to check because already goes to makes to false, so no need to check. And then, and next is 7. Let me make it small. Okay. Okay, let's make that 7. 7 is 7 is here I have seen that all are not, let's say here 5, in that all are not primes except 5, because 5 was not get 0, because 5 is not multiple of above numbers. So that's why it's not get done by anyone. So that's why we don't considering the first values of this. If it, see here, it is already 4 is a multiple of 2, that's why we don't considering the this type of multiple, fourth multiple. Okay, because already done by 2, so that's why we don't consider it. Same for, like, let's say for the 7. 7 was also not done by anyone from above 2, 3, 4, 5, 6. So other ones, so we need here need to only do done by the 7 only. Okay, so 7 gets zeros for 7, 7 twos or the 14, so it will takes the 14 to false. Okay, same as like 21 false, and same as like 7 multiples or makes to false. Okay, but here only we considering for in the range of numbers only, which is number is equal to 13. So that's why we are going to this only. Okay, same for the next 8th one, 9th one. 8 is also multiple of this, and 9 is also multiple of 3. So no need to check and make these multiples to 0 already by 3, because already makes zeros by 3, right? So that's why zeros means like false. Okay, false, 0 or anything we can consider. Okay, is all by done by 3 or like 2, or like already there multiple of things. For example, 10 multiple will done by 5, and 12 multiple done by 2, and 16 multiple done by 4. 4 also like or like a 2 only. Okay, 27 multiple done by 3. So no need to check with all these numbers. So just we seen that here doesn't makes false is numbers are true. 3, here like 5, here like 7, here like 11, 13. So these are the prime numbers, because do not touched by anyone. They have only uh, factors are 1 and the number itself, so that's why they are don't touched all these things. Just we done their multiples as 0, because their multiples will really as a non-primes, right? Because they will have the multiple factors. Okay, are you getting my point? So this is nothing but pre-computation. In the C exercise, like you can observe, they will mention which is pre-compute. Okay, I will show. Let's say here also, see, let's say here defining C as n plus 1. For example, n was given as 20. Then 20 plus 1 is equal to 21 times, means 0 to 20. Okay, are you getting my point? Here given 30. So 0 to 13 we getting my point. Okay, in that times we have make the true, and I am making the first value and 0th value as false, because zeros are not a primes. Okay, next, for doing this operation I am considering p means prime as 2, like firstly doing with 2. Here you can observe a pattern. Multiples of 2 or like doesn't touch by anyone, so these are like a prime numbers, they are not a multiple of anyone. Okay, others are get cancelled or making 0 or false. Okay, so for that, so for prime, the two factors. So here the thing is, when finding these things already marked by 2 or 3 or all these things we have seen in the book, I have said like 16 is marked by already by 2, all these things. So you can understand that for 3 in okay, let me see where I have written that. Here already marked as false for 2, and except 2 it was the multiple by them. Okay, next, and for the 3, 3 was same as like I have said 3 into 6, 6 done by already by 2, and 3 into 3, it is not done by anyone. Yes, which means it is done by only by 3. It is not marked by anyone. You should do by 3 only. Okay, and same for the 4, but it is already done by all these things by 2 only. Okay, already by 2 or 3 or anything, because already it is a 4 is a multiple of 2. 2 will do all these things. And 5 is also, this is also done by 2, and this is done by 3 already, and this is done by 2, and just 5 into 5 is done by only by 5. Here 4 multiple we don't consider, because it's already done by this thing. 4 into 4 is 16, 16 already done by 2, so we don't consider that. We only consider the 5 into 5 and 3 into 3, because that is should done by only by it number itself only, right? So we can observe that these things are the to start from, so we can start from that. So others are already done by previous, so we don't need to calculate from that, which means we can start the 3 value from uh, 3 into 3 only, because 3 into 2 done by 2 already above, and we start the value from 5 into 5, because 5 into 2 done by 2, and 5 into 3 done by 3, and 5 into 4 done by already by 2, which means these are the multiples of 2 and 3, right? And this is 4 is a multiple of 2, so we don't considering much that, but we will see that what will happen. Okay, mostly you can understand by 7, mostly like 7, 2 was done by 2 and 3 was 3. Okay, 3 sevens such thing was done by 3, and same as 2, and same as for the 5, because 5 into 5 will start from the 5 into 5, 5 into 6, 5 into 7 will happen by the 5. Okay, this means with this will already becomes a false, because it is not a prime numbers. Okay, by 2, by 3 or 5. Okay, so we start from n into n. Okay, which is p is equal to 2. This code executes, which means let's say first will be I'm considering 2, so p into 2, sorry, p is equal to 2 means 2 into 2 4. Let's say I'm saying n value is 20, 20 is less than or equal to, sorry, 4 is less than or equal to 20. Yes, so if that is true, means if save of p means in that array, which means in this array, if p means 2, okay, that second one is true, then execute this. Okay, so it is true, so it will execute from which range? 2 into 2, like I have said here, it will start from 2 into 2, 3 into 3, 4 5 into 4, 4 into 4, like that, but no need to do, because that already was done by 2. So it will does, but it will based on this. See, I have said that 4 into is done, not done, because it is already 4 was already multiplied by this one, second one, right? So it is false, so this will not execute. So the condition is if 4, let's say you can go to that, let's say 2, 2 into 2 is 4, 4 is less than 20 is this. So in the first value it doesn't return any true, because the 2 index value is always true, because never done by anyone, and 2 into 2 is 4 in the range of 21, and p times, here we doing the p times jump steps. Okay, because uh, you can understand that here, here I am written the code that how will go. So first take an array in the size and make this 0 and this loop 2 to n, 2 to n1, like same as like that, but another changed. just for finding the numbers. And here you can observe I have set the step 1 p. So for that p you can understand, say I will zoom, okay. So you can understand, for making false, make this I plus 1 so that the number gets false in that array starting from 2 into 1. Means just like doubling the value. Don't consider that, I am also will confuse. Just like for example 4, 4 plus 2 is 6, 6 plus 2 is 4, 8. So these are like two multiples. Same as like for 3, 3 plus 3 is 6 and 6 plus 3 is 9. Same as like 3 multiples. So we are making that multiples as false. So and again I am increasing. So it will becomes 3 into 3, 9. So 3 into 3, 9. 9 is less than 20. Yes, so it will goes into here. So here 3 value not done by anyone. So it will go into the condition. Then again checks that. Okay. Again checks and makes this as like and n value 21 and steps that and makes all the values 0. Next goes for the 4. 4 into 4 16. 16 is less than 20. Yes. So it will goes into that. And if 4 is true, no, it is false, right? Because it is already done by 2. So it doesn't executes or enter into this condition. Then again increases the value. 5 into 5 25. 25 is less than 20, no. So it will execute this. Means the while loop gets executes and return that CV. What is CV here? That array. That array, if that type of array means, for example in that second one is true, then it returns, okay, that value returns, okay, 2 was returns and checks for 3. 3 is true, yes, so it returns. And 4 is true, no, so it doesn't return. So that's why it is returning the C of etho this something eratos this themes, okay. So it will create a boolean, it will create a boolean list and making all the numbers are from initially and mark multiple of each number as false and remaining true indices are primes, okay. So these are the edge cases like large n. For example, this works efficiently but uses the extra memory, so we need to again reduce them. So and another edge case is less than 2, then handle to start, so output doesn't return anything. So time complexity is like this. As I said, it takes the more memory for this type of ranges. So I have used the approach to which is erathostis segmented. Are you getting that? Segmented means halving or anything, again using the square root type, okay. So this is the segmented C. Means it, you can observe this, when you need to primes between two large numbers, then we need to use this in a simple way, okay. You can't normally understand all these things same as like that we done above. For example, I'm scrolling up here, we have done same as like taking an array and making this false and checking with each number, same as like giving the same of the like these numbers and checking with all this is if it is in the prime or not false and returning that array, and we checking and we returning that numbers. So here let's show that a real for example that what we can say, this approach has, right, for example this approach have the full code which is nothing but like this, okay. You can understand very slowly, okay. This is like same, you can observe this save primes, it is a function but we can't see anywhere here in this program, okay. So it it indicates that it is save primes like in this it is. So you can get that sieve of eratos this like segmented version is that comes from the extended version of that. And time complexity, you can observe that it will reduces, and Same as that of space complexity. I think it will not, but space complexity was really reduced. You can observe that. Okay, so let's get into that program. Same as like that above we have done. First, like for example, I am defining a generate a function, same as like we done in the, for example, I'm scrolling up here, we done in the approach 4. Same, you can observe that we defining, and this is also same, but just like defining to find is this prime or not in that range, to return that or not. Okay, so same as like that. Okay, and same as like that. Yes, just here used only the for loop, they used only for while loop. Okay, that is not much. Okay, so and return that array. Okay, that's fine, but here the main point is, here this is the main point of the function. Okay, segmented sieve. Segmented sieve algorithm for the finding primes in a range of this. So the edge case is like we normally return that, and the step 1 in this segmented approach. Okay, generate the base primes up to square root of n, which means here we using the sieve primes, which is I have shown. Let's say I'm scrolling down, I'm showing this approach, segmented approach. Here I said they use this. So in this, okay, in this it is using limit. What is limit? It is showing that this. So you can observe that generate base primes up to square root n. Here the main point in this also, we just taking the primes of the end value, like just like square rooting. Okay, let's say the, let's say for example 40, let's say start value is 40 and end value is 60. Let's say we can make that, for example I'm clearing this, and 60 root of this, it almost like 7.7. So me making this into int, so almost like 7. So they want 7 prime numbers. I mean we are giving the range. Here we giving the range, and this I'm scrolling up, and this take that limit and gives and makes that 7 type of array, size array, and makes the first things, and lastly gives that array which is true or false of the prime numbers in that 7 array. Normally we get 7 primes means 2 3 5 7 11 13 and 17. Okay, is that 1 2 3 4 5 6 7? Okay, 7 primes we get. Okay, 7 primes. So we get the 7 primes, and see we saved that in the base primes. In this variable we have used this, so we only need the prime numbers in this and get the prime numbers up to this root of last number. So I am listing that primes. Okay, you can observe this, list the primes to use the marking multiples. You can understand, just here I am creating a variable of list. In that I am using list comprehension, that here this function returns a array, which is in that array 7 size of array, and returns that it is true or false of that 7 numbers, mostly like these numbers. Okay, and that returns an array. So here base primes is also an array. So if in that array have any of true, so okay, if in that array any of true, if true, then returns that index number, which means it is a prime number. Okay, because it starts from 2 and limits like this. Okay, so list of primes, so it is a list of primes, just like it's a basic primes, not like using in this range. Okay, just like we considering it is in the base of primes. Okay, so here the list of primes we have listed in this. Now here the main point we will get. I'm scrolling up slowly. Okay, so here I am creating a boolean array in the range of this. So for example, my start value is 40 and end value is 60. So by doing 60 minus 40 is equal to 20, which means like normally 40 to 60 we have the 20 size of array, or like 20 size of numbers difference, like size in that terms of size. So we do that, and list of primes for marking. Okay, you can observe that. Okay, sorry, create a boolean array for the range of this, initialize to true. So I am initializing true with into, in I'm creating an array in n minus start plus 1. Okay, in n minus start plus 1. True means the number is potentially, we are assuming like prime, and false is means it is not a prime. Okay, and after that we make that. So mark the non-primes. Now we need to mark the non-primes. How we will mark the non-primes? Because we just created an array. Okay, now and use this array for creating a small prime numbers. By these things, how we create that, and in this range we get the prime numbers means, here we are assuming, or here we are dumbly creating, assuming that this array, which means 20 size array, that 0 1 2 3 4 5 6, these are all our indexes, right, from 0 to 21, because in this range I am using plus 1, right? So in that it will assumes like 0 to 21. So it is a dummy. 0 means like we are assuming 0 is index is equals to 40, and 0 1 is like 1 index is equal to 41. So we are assuming like that by like dummy d. Okay, so calculate the first multiple. Now we need to make that array to false, which is multiples of that. So we are taking the multiples of which is greater than 40, not from 2 3 4 5 6. Okay, by using this array or primes, I am using this. You can observe here, calculate, mark the non-primes in the range, and calculate the first multiple of p within the range. Okay, so here let's say I'm creating here the first multiple how we get. Okay, let's say in the prime numbers I have said, let's say I'm taking this. Okay, in the first prime is 2. 2 into 2 is 4. So here 2 into 2 is 4. After that, and start value here is normally a 40. 40 to 60, right? 40 plus 2 is 42. 42 minus 1 is 41. Okay, and we are doing the, it's like a non-decimal type. Okay, and giving directly an integer type. So doing this means here only doing this. After that we multiplying, doubling that, or like 3 times. Okay, which is 40. So you can observe that here we get the 2 multiple in the range of this, which is 40. So 40 is divisible by 2. So it is a 2 multiple. So we make that 2 multiples to 0. So first multiple of the is 40, and we now mark all 2 multiples from 40. This includes these type of array until that end we can make to 0. After marking this will look like this. First value 0 and 0 value 0 by 2 2 2 2, just like 40. See, I'm said like I'm dumbly created and assuming that 40 will start from this, and last value 60. 60 is like a multiple of 2. So we have same as like p3. Next we will calculate the prime this, next 3 into 3, and doing this, and same as like 42 divided by 3 is 14, and into 3 42. So the first multiple of 2 in the range is 42. So we just making the array false by just multiples of 3 from 42. So we don't considering the previous things like 40 previous things. Okay, and after 60 things we only considering in this range only. So 42 40, these are like a 60. So we making that values also 0 until that last. So after marking look like this, and same as like same next prime number is 5 and next prime number is 3, so 7 like this. And now we calculate same for like this, and 5 into 5, and start is like this. We get the 40 because 40 is a multiple of 5, so we all mark them as 6 like this, like false. And next 7 prime number, same as like that, makes that this, and we get only 2 3 5 7. I think until 7, I think so. So it's my mistake. Let's say I'm see here. Generate the base primes. We need to find the primes up to square root of n, and it's approximately like this. So we generate primes up to 7. Okay, okay. It's my mistake. So up to 7 only. So it is up to 7. So use the size or the something like this and create a boolean array by using these primes. Okay. So let's say I'm scrolling up. After that, we need to collect prime. Now we go through the series and collect all the primes and still marked as true. So who was marked as true, we just takes that, and the number are still 2, are at the positions are the prime numbers. Okay. And conclusion is like, after going through these base primes and marking their multiples, we are left with the prime numbers between 40 and 60 or these. So the line means like just like this was marking the correct number whether it is at least or not. Okay, just like I have given this and asked about this. So it is, sorry, it is like only 7, up to 7 only. Okay, so for that, yeah, yeah, okay, like limit and 7, so to 7 only. I just thinking it like count. Okay, it is given like up to 7 only. So okay, so we have to, for that, making up and doubling all this thing, and means in that array, they said like, for example, here 2 and 3 3 times 3 times 3 times, so it is like a multiples and making that false. Mark that position. Here I minus start is like a, I is like first multiple, for example 42. 42 minus start value 40 is makes false. So or like a next 42, after that, yeah, sorry, 40 minus 40, we get, can't do that. And same as like that, again you can slowly understand. So collect all the written all these times in the list comprehension. So here we can understand, if this in this way, here what is sieve range? Yes, sieve range, where it is. Okay, okay, we have created already, true that. Okay, so in that range, I means index of 42. Just like we are getting index numbers, you can understand here. Here for example, let's take this two multiples 40. So 40 minus start value is normally 40. 40 minus 40 is 0, so makes false. Next 42 minus 40 makes false, means second index. Okay, next 44 minus 40 means fourth index, means that's just like minusing, false. And next 46 minus 46 index, so it is like a making multiples of that. But it also takes the multiples again p. First multiple, it is like 42. Okay, it already gets generated and used in that. Okay, so we already get the first multiple as 40 and in that range of 61. Okay, and doubling, so we get this type of array and we are need to make that to false, right? So we are done by just like indexing things. Okay, so these things I have observed from this. So in this video, this is the completion for that. So let's, okay, in that last, okay, I'm just doing this what the edge cases was given. It generates this normal sieve and then use the those primes to mark multiples in this given range. So use case is for the very large ranges only, means like when we unit, and time complexity and space complexity is like this. So summary given like what is when we get the large and whatever, and constraints are like in a range in the given. For example, in exam they will give the constraint of numbers, then how you will solve, then what will the time complexity we will get, then we use this sieve of erathosthenes something approach. Okay, for that it will, they will give such type of constraint to check that time complexity we can solve or not, that type of thing we think. So best for this is like interviews or anything, use this. This is the basic approach because it is a simple and basic and easily we get the more clean and efficient and understandable logic also. Okay, it is like a fastest, but yeah, here you can understand pre-compute primes and optimization understand. Okay, next day 16 is like Armstrong or like Fibonacci series something. Okay, so to solve this we have used almost 5 approaches, which is first one like a easy approach but just like going through each primes and not doing any square root methods and any flags. And in second approach it does by all these things and given the edge cases also, so it will be better much. And here just uses a small helper function just like this to prime or not. And next approach is like C of Eratosthenes. In this also it is also very good, just like giving array and checking is the prime or not, in that way returning all true false some such things. And that segmented and that extended version is like this and uses that above approach also by just here by doing the base primes. Okay, so these are things from my side and thank you. And in next video we are going to solve the day 16 or revision. So see you in the next video.